Hello, hello, and welcome to today's webinar. I'm so glad you're here. We have a terrific group on today's webinar. Look forward to it. My name is Jeffrey Palermo, and I am a chief architect at ClearMeasure. And we're going to talk today about DevSecOps, intentionally designing security into your DevOps environment. And there's a lot of information to get through. If you've never done a Zoom webinar before, there's a Q&A window where you can ask questions. There's some information that will get to you through the chat window. I have some resources that I'll mention, and we'll put links to those in there, as well as giving you my email address to follow up afterwards. But just overall, we're going to talk about quite a few things. There's no way to go deep in each of the topics that we're going to talk about. But if any of these topics is interesting to you, then just give us a call, send an email, and we can help you with any of the topics. Security, it's an aspect of quality that has to be a focus on each stop of your software process. And everyone, really, if you've been around the industry for a while, has either been involved directly with or has even heard about a breach of security failure that can result in major losses, or has resulted in major losses for a company. And as somebody shipping custom software, you bear a large responsibility for operating the software in a world where would-be attackers are constantly searching for vulnerabilities. And this webinar is going to provide an architectural overview of DevSecOps. That is a DevOps environment that has security designed into each part of it. And we'll go over the way that you should cast your security vision, as well as the strategies that you should employ when designing it in. And we'll go over in some detail some of the tools and known best practices, like the STRIDE model and the OWASP Top 10. And so we're gonna go into that DevOps environment and how to design security into it, so that you can really gain all the benefit of DevSecOps. All right, and as we go into it, for those of you who, now we have a lot of repeat webinar attendees here, so welcome. We're glad you're finding value in the webinar series. ClearMeasure is a Texas-based but national software architecture company that is empowering software delivery enabled in-house .NET teams to be self-sufficient, able to move fast, deliver quality, and to run their systems with confidence. And so as a architecture company, it gives us tremendous joy to come alongside, advise, and help existing in-house .NET software development teams to really be world-class in delivering custom software, so that you can outsource less, so that you can do more in-house and just have a higher capability software team. So now we are hiring various roles. clearmeasure.com/careers. If you have any friends out there in the industry who happen to be looking for an architect position, or software engineers who would like to grow to become an architect, if you have any friends that fit that. A little bit about me, just to make this a little bit more personal. My hobby is motorcycles, and has been all along. I kind of do the amateur off-road racing series. Not that good, but it's fun, and that's what a hobby is. Some people have hobbies that are golf, and they're never going to go on a tour or competition. My hobby is motorcycles, and I like the off-road dirt biking at the moment. All three of my kids, one son and two daughters, have done dirt bike races in their own categories, and that's my boy. Changing a tube is one of his tires. And we live just to the west of Austin, kind of out past all the suburbs out in the country, where we can kind of have some livestock and get some chickens and whatnot. So that's fun, and that's me. And by the way, if anybody wants to send me an email asking about what it's like to get a dozen eggs a day out of your chicken coop, by all means. But today's session, all right, we're going to start by talking about DevSecOps thinking. Remember, we have a DevOps environment, but we want to intentionally bake security into that process that our DevOps environment is facilitating for us. Okay, we're gonna touch on some things around physical security. We're going to talk about some things for baking in security controls into our code, and then into the documents that surround the software project, because every software project has tons of documents. We'll talk about security when it comes time to deploy across various environments, including deploying to production. And we'll talk about a few just frameworks and bits of guidance that are available to anybody, like the STRIDE model. And then we'll talk about runtime security while the software is operating in the production environment. Now, the basis for this, of course, is a DevOps environment, because if we're going to bake security into a DevOps environment, we have to have that. I do want to offer a free electronic copy to anyone who would like it. My latest book, .NET DevOps for Azure. You can get it anywhere books are sold, but just for being on this webinar, if you would like a electronic copy of this book, I'd be happy to personally send one to you. So just we do not have it available for download, but if you send me an email, and we have an e-form that effectively just sends you an email too, you can get that in the chat window. But if you send me an email, then I'll make sure that you get an electronic copy of that book. And then also, we talk about quite a bit of security topics. If you're not aware of the podcast that ClearMeasure sponsors and makes happen, it's the Azure DevOps podcast. I'm the host of it, been doing it since 2018, and it has all kinds of interesting guests and industry experts about all types related to shipping software on the Microsoft platform. So that's another resource for you. And you can find that pretty much any podcast directory. And then we also have some interesting video content that is available. ClearMeasure, just look up the ClearMeasure YouTube channel for architect tips. Specifically, you can go to architecttips.clearmeasure.com. Okay, so let's get into it. We have a lot of content and we have a short amount of time, but I like to be respectful of your time here, and we reserve an hour for the webinar, but I know that you guys have stuff to do. So if we can get through it, in less time than reserved, that's great, but I will make the commitment to you, depending on the volume of questions, a lot of which I can just slipstream straight into the content. But I will not close the webinar until we got all the questions answered. And if we really run out of time, I'll even do consultations with you after the fact if we have some questions that are not answered. And of course, you've got my email address. So I want to make sure all your questions are answered. All right, let's get into the DevSecOps thinking. So it starts with the DevOps environment. And this is a highly shrunken technical blueprint for the structure and flow of a DevOps environment that happens to be implemented with Azure DevOps Services and Octopus Deploy and Redgate, which are really popular tools. But ultimately, you could implement it with anything: TeamCity, GitHub Actions. Whatever. The tools are secondary. The process is primary. And look at the box of scenarios. Your DevOps environment needs to, at a minimum, have the ability to execute these scenarios. And so you need to have starting with continuous integration, which is a 3-stage process. A lot of people implement a integration build with the team, but they don't have a private build yet for the individual developer workstation. So the private build is very, very important. It's very, very important that every software engineer on the team be able to run the private build locally with no network connectivity whatsoever, and have it run all the unit tests and the component level integration tests, and build the database locally, and make sure that the changes locally are even ready to be shared with the team. And then, of course, the integration build is the second stage of continuous integration. And then the first deployment is the third stage of continuous integration, where we deploy to a real environment and then run full system tests. We do encounter a lot of clients that have only implemented 1 or 2 of the phases of continuous integration. And so we go all the way back to the 2006 book that literally is titled Continuous Integration. And then there was a sequel, not a sequel, but a follow-on book in 2009 called Continuous Delivery, that cited the book on continuous integration. And so if you've never heard of that book, never read that book, or your team hasn't, just go get the book. I mean, at this point, it's what, 16 years old, but it defines what continuous integration is. And those 3 stages are very, very important. You want to make sure that you have all 3 stages of continuous integration in your DevOps environment. And then when it comes to deploying, you want to make sure that you have your minimum of 3 environments to deploy to. And of course, the first one is that continuous integration based environment. I like to call it the TDD environment because it runs full system acceptance tests. And TDD invokes, the name test driven development. And we are running automated tests there. That type of environment, no humans are really allowed on it. There's no point, because the automation is deploying an application, however many deployed components that application has, starting it all up, running the test suite, and then throwing it all away. So no people are really using that for anything. It's just for the automation. It's for that 3rd stage of continuous integration. And then of course you need your production environment. You need at least one of those. And then backing off from production, you need some environment to do manual testing. The most common name is UAT, user acceptance testing. But you need at least one environment to do manual testing. A lot of companies have multiple different environments with all kinds of different names for manual testing. They have manual testing environments named dev, test, UAT, staging, sit, dit. There's all kinds of names for environments where humans check out something on the software. Those are manual test environments. So obviously you need at least one of those. A lot of companies like to have multiple, and that's great. For all of these 3 categories of environments, you need at least one of each to have a complete DevOps environment. And so we're going to talk about this general structure and how to integrate security concerns with a lot of these areas. Okay. Now, this, by the way, from a resource perspective, this poster, this is just the top 1/3 of this DevOps architecture poster. This is actually the full poster. Obviously, you can't read all the text, but if you are interested in a high resolution copy of this full DevOps architecture poster, then just let us know. This one, you can click a link and just download it. And later, if you want a team member to have it, just send me an email again, and we'll make sure to get it to you. But this is high resolution. It's meant to be printed at a print shop on 2 foot wide by 3 foot tall poster paper. A lot of people like to do it on the foam board, so it stands up on its own, or put it on a wall of a team room, things like that. All right. So that's the DevOps environment, the general structure that we're working with. And from a training perspective, you want to make sure that everybody on your team at least has some baseline knowledge. I really like KnowBe4 as a training company. Just look them up. They have curriculum. They will actually attempt to do social engineering against the people on your team, and then report to everybody who's been hacked, kind of like in a simulated attack. I mean, they'll send creative emails, enticing people to click, impersonating people in the company. They'll do what the real attackers are doing. And so it helps everybody on the team understand the tactics that are out there and be educated and be watchful for those. So I really like the KnowBe4 training. Also, just a great resource to be aware of is staysafeonline.org. And by the way, this is for your team, this is for your family, this is for everybody. And it's from the National Cybersecurity Alliance. There's a lot of information there. Everybody should just know what's available through the National Cybersecurity Alliance. October tends to be National Cybersecurity Awareness Month. So, coming up in October this fall, it's a great time to integrate some month-themed training. But everyone needs to realize that attacks are always happening. It never stops, regardless of what type of attacks. They're always happening. And anyone who's worked related to and had access to firewall logs, you can see that people, whether they be real people or a ton of just automated bots on the internet, are constantly trying to get into various things. And so you just need to be aware of it. But before we get into the team-based security controls, individuals must be aware of what's going on. And so that's why it's so important to have individual security training. And whether again, this is not just for developers, but even for software users, because anyone who uses software that exposes company sensitive data is going to be a target. And if their user account, if their access gets compromised, then the data that they have access to becomes compromised. And so from a software feature perspective, you really don't want to be, I'll just throw out one example. One example that I would consider naive is if you have a software application where you literally don't know if there is somebody just trying to do a brute force password attack, whether it's an automated bot or a real person that's just over and over putting in a known username or known email address, and they're just guessing passwords all day long. And so you see in some software, if you try with a bad password 3 times in a row, it locks out the account for some period of time. That's one of the mitigations. But if you were to be honest with yourself and think, okay, every one of our applications, do I know for a fact that somebody can't just sit there all day trying to guess passwords without us knowing? Well, that's a good discussion to have. All right, that's an example. All right, let's talk about physical security at the individual level. Now, we've heard about VPN all day long, but the threat here when it comes to the individual level is actual data and files on an individual computer. And with so many people who work with software and software engineers working from home, working from co-working spaces, or generally carrying around the computer, you have to think about things like this. So even before we get into the shared team environment for software, it starts with the engineer workstation, because the engineer workstation has the Git repository on your computer. It has the source code and it has some data. Now, there are practices that we have talked about a lot when it comes to cloning and masking and making sure that none of the data sets that the software engineers use have actual production sensitive data. And there are techniques to make sure that you do not have any sensitive data when going from a production backup, in the cases that you have to do that temporarily, but more importantly, being able to generate sets of data from an automated perspective, so that the source of the data that we work with never came from real data in the first place. But sometimes when you're debugging a performance issue and you really need the shape of the data in production, it's common and sometimes necessary to have an environment where you do some sort of backup restore from a production database, but make sure that you have masked or gotten rid of the sensitive data columns in that particular database, while still being able to do some type of performance debugging. And so whether it's that, or whether it's just having documents, OneDrive, Google Drive, Dropbox, it synchronizes data files onto the computer. And so there's network sniffers, but if your computer is mobile and someone's carrying it around in a backpack, it can be lost. So when it's lost, the question is, have we actually put in place some security controls to make sure that the data on that computer cannot be compromised? So that's where using Active Directory, Microsoft 360 logins, and BitLocker come in. And some of you might be saying, oh, these are just the basics. These are just the tickets to the game. Okay, that may be so. But how many of us have used maybe some contractors on a particular project where that contractor, we needed to give them access to Dropbox or OneDrive, or we needed to email them some stuff, or obviously we needed to give them access to the Git repository. So corporately, we may have those controls, but what about the contractors that have the same amount of data? Okay, we need to think about that. So that's one point. Now, at home, think about the networks that we're using. Now, it's fine to use regular home DSL, cable modem, internet connection, but just like when thinking about Sarbanes-Oxley compliance, SOC 2, PCI compliance, when designing the architecture of a software system that's handling financial or healthcare information, the same themes come up. And that is, how is data moving between computers, and how is data sitting in a storage state at rest? And always the same two things. Encryption. Is data encrypted at rest? And is data encrypted in transit? And so we work those into the architecture of the software systems, because in those spaces, it's normal for the software system itself to be audited. If you're doing financial transactions or healthcare, or even FERPA with software that deals with student information, K through 12, college, but all the same audits tend to be themed in a similar way. Do you have existing controls to mitigate threats? And one of the most common one of those common controls is encryption in transit, encryption at rest. And so VPN gives us that encryption in transit. BitLocker gives us encryption at rest. But at the same time, if other traffic of the computer is going across a network where other devices can just constantly try to pick and port scan, that's one thing we need to think about as well. So we need to intentionally just do a little bit of inspection on the networks that our individual team members are using. And most routers that they already have either support a separate network, or at a minimum creating a VLAN, so that it becomes impossible for a compromised device on their network to just sit there all day port scanning or attempting to find some sort of vulnerability in their workstation. So that's another good recommendation for you. And then the last point on physical security is recognize that your passwords are compromised. Unless you've already done this, and have done it probably a few times, I guarantee you that if you go onto any of the online password checkers, or the one built into Edge, one's built into Chrome, and just look for compromised passwords, you will find reports where literally your username and password that you used on some particular service was lost in a data breach. Okay, now it could have been you bought a movie ticket on fandango.com, and you gave it your email address and some password that you didn't use with anyone else. Okay, well, that's good. Now, chances are a lot of people, they might have used a password that they did use with another service. Well, whether or not that's true, they now have your email address that you use for online accounts. Now, how many people use the same email address for accounts with multiple service providers? And because that's true, well, now they have a list of accounts at all kinds of service providers to just check and see if they can do brute force attacks, dictionary attacks, use all of your other passwords to see if you reused one. So be aware that your passwords have leaked, every single one of us. And it's really important to use a password manager. I currently use LastPass for personal, and then we have enterprise level LastPass as well, that allows the temporary sharing of credentials, and also schedules to rotate credentials. But it makes it super accessible, but it also effectively gives me a unique, long gobbledygook password that I would never remember in the first place for every different account. And then finally, because we're using so much on our phone, really look for the tampering of your phone. It is possible, and there's been plenty of reports of tampering and cloning of a SIM card so that two-factor authentication SMS messages get sent to somebody else in addition to you. And so you definitely look for evidence that your SIM card has been taken out and put back in, and you can add tamper detection, like putting a piece of tape at a minimum over that little SIM card slot. And of course, on all of your accounts, two-factor authentication helps a whole lot. It's something plus something you have. That's kind of the theory of two-factor authentication. All right, let's get into the code. All right, code security. So now we're at the Git repository. We have intellectual property, that is the source code, and we want to integrate some security controls to make it less likely that intellectual property will be compromised. And of course, there's two threats that I want to really dive into. One threat is unintended access or theft of the actual source code. And the other threat is malware injection, where literally code gets into your software that you didn't want to get into your software. And so on unintended access, usernames and passwords, that's going to be the most risky. You can add two-factor authentication. That's your solution for the independent access. But for let's say your GitHub account or wherever you host your source code, you're going to have an account that has access. Use the first recommendation is to use team-based access for each repository. Don't grant access to individuals, because then when that individual leaves the team or changes roles and you need to remove them, now it's up to separate record keeping for what team they were on and what Git repositories they now don't need access to. And so if you use team-based access, then that record keeping is baked into it, because the ABC team will have access to these 7 Git repositories. So if they're removed from the ABC team, then instantly they get the proper repositories restricted. And then you also want to go through every now and then have a schedule for the removal of non-active committers or readers, especially readers. Oftentimes somebody needs to do a review or have temporary read-only access to the code. And unfortunately, I'm not aware of any tools that say, oh, give someone permission or give someone access with an expiration. So we have to remember to expire these and take that away. All right, on the malware injection, static code analysis is your friend. SonarQube has features that inspect security and also inspect security vulnerabilities of NuGet packages that you happen to rely on, not just your code, but the code of packages, because there are so many packages with known vulnerabilities, and many of these packages are patched and the vulnerability has been fixed, but only if you upgrade the version of that particular package. Now, you do not want to have a blanket greater than or equal to on the version, because that right there is just opening you up for all kinds of attacks, like what happened in the fall or last year with NPM with the UA parser.js hack. And NPM, there's been a number of these in NPM, and I think it's just a matter of time before it happens at NuGet as well, where there's some open source project that has some committers' credentials compromised. And guess what? Good open source projects have continuous integration with automated functional tests and automated publishing of new libraries. So you don't actually have to have the package manager's credentials to publish a new one. If you just get a committers and, oh, we're accepting this pull request along with some nefarious code. And so that can happen. And so you want to make sure that every change to your code, which includes versions of packages, insist on pull requests so that people are taking, and put review of dependency changes on the checklist by which you approve pull requests. Okay, that gives you more chance to detect if we're upgrading a version of a package, but we really hadn't planned to update that version. Also, again, I said this already, you don't want to have blanket greater than or equal to version number on your package references in NuGet. You want to make sure to reference a particular version and update intentionally. Have a person update it, because a nefarious hacker, when they publish a new version of these packages, they're not going to do a major revision and say it's version 3 instead of version 2. No, they're going to say this is version 2.45.1. And so it's really popular to have greater than or equal 2.45 star, so that we can just automatically get these minor patches. Well, guess what? The hacker is going to classify whatever they did as a quote minor bug fix, so that all these people that have these greater than or equal to version dependencies, guess what? They just automatically get this new version with the bad code. So be aware of that. Okay, so let's talk through just the general structure of what your build flow should look like in your DevOps environment, so we can talk about where security fits. But your private build and your continuous integration build, they're going to share the build script, and they're going to do a lot of the same things. They're going to clean the local directory of past build artifacts. They're going to stamp a version number. They're going to create the database that's used for that particular build. They're going to do the compilation. They're going to run unit tests and component level integration tests. But your integration build continues on and runs your static code analysis rule sets. And you should not only run the analyzers, the not FXCOP, but your Roslyn analyzers. Now, make sure that you select the rule sets and add additional rule sets. SonarQube, Independ. There are so many static analysis rule sets out there that are security checks. There's really no reason for not using them. A lot of them are free and so affordable. And so the integration build, you really need to have that package bundled in. But the integration build continues on, publishes test results, and then packages up the deployable release candidate packages and publishes those out to Azure Artifacts or GitHub or wherever you do it. Then when one of your developers has done that, and you actually have done the committing and we're on the master branch, this is the flow of a pull request. And when I say add security related things to your checklist by which you do your pull request inspection, I really literally do mean to elevate your pull request process up to the status of a formal inspection. Capers-Jones in his research has shown that there are 3 quality control methods that reliably elevate teams' delivery quality up to the high 99% defect removal before production. And the one of them is testing. One of them is static analysis, and the other is formal inspections. So testing, if your team is doing test-driven development and continuous integration, then you are doing the testing that is shown in the research. And make sure you're doing all 3 levels and more of automated testing: unit tests, component level integration tests, and full system acceptance tests. And then static code analysis, we talked about that. And the third is formal inspections. A pull request checklist is the most practical implementation of a formal inspection. When someone has done something on a branch and they're ready to push it into the master branch, well, guess what? You got an inspection. And instead of just saying, oh, the coding style, and I like what you did, no, make it a checklist. If really highly trained people like doctors and airline pilots rely on checklists, then we can too. And so just decide what the checklist is going to be and put it in there and have everybody just, when they click that button, accept pull request, It's saying, on my honor, I have verified that the changes represented in this pull request do in fact satisfy all of the items on this checklist, and I'm clicking the approve button. And you know what? During your normal retrospective process, when you talk about it, you ask the question from time to time, whether it's based on a bug slipping through or something. Hey, is our pull request inspection checklist still sufficient, or should it be changed in any way? All right. And if you want to change it, you change it and you move forward. All right, so that's how to integrate those related to the code. Let's talk about document security a little bit. Document security is actually not very complicated. OneDrive is actually pretty darn good, and it supports HIPAA and auditability. SharePoint over OneDrive adds team-based access, and so that's good rather than just vanilla OneDrive. And Google Drive and Dropbox are good as well. I don't know exactly if they have all of the capabilities that OneDrive has when it comes to auditing, when it comes to defending yourself in the midst of a HIPAA audit, like we have personal experience with HIPAA audits and the teams that have used OneDrive and SharePoint. But also think about the documents on local workstations and your email, and whenever you download, and you have your downloads folder just on the workstation. Think about those as well. But if you really drive processes that push your team to view, save, and access files through SharePoint OneDrive integration, then a lot of this protection is going to be done for you. And if you have regular routines that clear out and delete local downloads and email attachments, that's great. Now, from a team process perspective and a point of training, discourage people from emailing document attachments. If you're on the same team anyway, you should just be emailing a link to the document in the SharePoint team drive. And then you're accessing it through OneDrive anyway, and any local downloads are temporary in nature, and then OneDrive cleans up disk space and all that. All right, let's talk about deployment security. And this is when we are actually deploying to pre-production environments as well as production environments, because anytime we're going to have just fill in the blank credentials in our config files just so that the application can run locally with no sensitive data. But especially as we get to UAT or staging environments and then a production, we're going to have some credentials that access real things even before production. For example, if you integrate payments with PayPal, you're going to have credentials to a real PayPal account of some sort. So you're going to have credentials in a non-production environment, and so you still need to have production level controls, because for the people who are testing your software, that's their production environment, okay? Even though we don't call it that. Just like a TDD environment is your developer's production environment, and the build server is the developer's production environment. If the build server goes down, it's a 7-1 issue from a developer's perspective. Yeah, the users of your end software, they don't even know or care, but for the developers, that's a 7-1 issue. That's their production environment. They can't do their job because the build server is down. All right, enough of that soapbox. But when it comes to credentials, again, use LastPass, use Azure Key Vault. Most of the time, it's sufficient to use a secret store and then put those secrets in a encrypted key value pair in Octopus Deploy or Azure Pipelines, because those tools keep them as one-way encrypted tokens, and they can't be reversed out. So do that. And then build your variables, such as connection strings, build them by embedding secrets using the tokens, as opposed to putting them in as literals and then repeating them, because your connection string is going to be a little bit long, and part of it is sensitive and other parts is not sensitive. So you don't want to have, if you don't embed the variables, then it's going to be tempting for the team not to press that little lock button and encrypt it, because then they can't see any of it. So you want to use the encryption. And then whenever the debug output is being emitted to the logs, if something came from a secret variable, you're only going to see some asterisk in the logs. It will not output to any of the debug logs something that came from a secret variable. Okay. And then in the environment itself, a lot of times, if we have access to a, well, pre-production environment or production environment, it's normal for developers to have some sort of, whether it's through the Kudu console or SSH, or in some cases, FTP, if you're still using it, access to the directories on the server that the code went to or the assemblies went to. Well, that's where the app settings.json is, with the the secrets poked into it. So take care that we're not giving unnecessary access to the actual server directories to people that really don't need access to that. All right. So this is how you should be thinking about the structure of your deployment pipeline. And again, this is modeled with the absolute minimum number of environments that you will ever have, which is 3. Because again, you need, there are 3 unique types of environments in a DevOps environment, and you need at least 1 of each. The production environment, the environment in which you're going to do some sort of manual testing, manual checking, and then the TDD environment, which is for automated tests, okay? And so the process that should happen is, on your build server, it runs the integration build and it produces your release candidate. Now, your release candidate, again, can have multiple packages, because an application, it's very common to have a website and a database, and maybe a backend job, and maybe a web service, and maybe a little desktop system tray, WPF application. So however many unique processes need to be deployed to deploy this version, well, that's how many NuGet packages you're going to have, or zip files you're going to have, or little miniature Docker containers you're going to have. But that all represents a single release candidate. It has a name, it has a version, and we're going to store that in Azure Artifacts. Now, there's other solutions, but if you're using Azure Pipelines, Azure Artifacts is the go-to store. It is a full-blown NuGet server. And so we're going to, when we deploy to a particular environment, we are going to have our automation go to Azure Artifacts and ask for the release candidate of application A, version such and such. And then our automation script is going to deploy all of the deployable packages of that release candidate to the target environment. It doesn't matter if it's the TDD environment, the UAT environment, the production environment, the process is the same. That means that by the time we deployed to the production environment, we're going and getting the exact release candidate, same version from NuGet, from Azure Artifacts, and we're running the same script to deploy it to the production environment. There are some people in this industry that have processes that, I'm going to air quotes, that quote, build to UAT and quote, build to production. And what it's actually doing is going back to the Git repository and recompiling from source, and then putting together a new package that has never had the acceptance test run against it, and that has never had any testing run against it, and deploying it to the UAT environment or the production environment. And that opens up the door for things to get in. Okay. If you always go back to your Azure Artifact store and get the same release candidate that has previously had every other security control run against it, you are minimizing the surface area where it's possible for some nefarious code to get in there. If you're doing a recompile to UAT, a recompile to production, well, guess what? Unless you've explicitly checked in every single package, which is less common these days, it's also going and saying, hey, NPM, hey, NuGet, Are there any new packages that I should download on the fly? Okay, let me download this package again on the spot because I'm producing this new release candidate package. that's why that UA parser.js, that's why it was so widespread, because so many people do that process. All right, let's talk about the stride model. This is a way to model threats. This is not going to be a deep dive into it. If you're already using it, that's fantastic. For those of you who are not using it, I want you to be aware that it exists, and it's a model for identifying threats. Okay, so when you are prioritizing features and designing extensions, enhancements to your software, think about, and especially the people doing the testing of the software too, think about the possibility, the ways that somebody would be able to spoof the identity of a user of the software. Think about the vectors, the surface area where it might be possible for someone to tamper with the data, for repudiation, for information disclosure, for denial of service, or for elevation of privilege. Okay, now just do some internet search. If you've never heard of this model, do some internet searches, read up on it, because there is so much low-hanging fruit in just asking the questions on these 6 different areas. How would somebody try to do this in this area? How would they try to spoof? How would they try to tamper? How would they try to deny service? There's value in asking the questions. There's a lot of low-hanging fruit just by asking the questions, and making sure that you've done everything reasonable to start with. Like repudiation, that's a weird word, but it's a user being able to deny performing of an action, saying, I didn't do that. A common challenge is digital signatures and being able to prove that a particular person made an approval or signed a document or executed a transaction. And what if that person is able to do something, but then later on come back and say, well, I didn't actually do that. So that's repudiation. All right, so there's a lot of things here. Let's go up to the 30,000 foot model and say, okay, how do I integrate a lot of this into my process? Well, the DevOps environment is kind of guided by an overall 12-step process. And that's what you see here on the screen. The top 4 are things that we do to decide what changes to make in the software. The middle row is the actual act of changing code and getting ready a change in the software, from typing code to getting to a new release candidate that's in Azure Artifacts. And then the bottom row is actually promoting a release candidate through real environments to the point where users are actually using it in production, and we can see telemetry of them using it and how it's going in production. And so we take this and we flatten it out onto a Kanban style board, and every project tracking tool has the ability to have Kanban style boards. And so this is what I consider your very average kind of minimal or normal Kanban board with all the different columns, where you see right in the middle of it development, where people are actually writing code, and there's coding tasks and there's commits to the Git repository happening. The columns before it are some type of decision about what change are we going to make. And the first one, you could rename it requirements gathering. Well, I like to call that conceptual definition, just to be more specific, but I don't care what you name these columns, but get the gist of it here. Conceptual definition is what we're trying to accomplish. And then we move on to user experience design, which is asking ourselves the question, how is a person actually going to use this new software capability? Even a batch job that just moves data in the background has a user experience, because data being from point A to point B every 5 seconds is a very different user experience than data being from point A to point B every 24 hours and being in some system room, oh yeah, that fresh data is going to be here tomorrow. Okay, so absolutely every change to the software has some type of user experience. It doesn't just always have to be with the eyeballs, but certainly storyboards and screen layouts would definitely be in that column. And then the next is technical design. That's where architectural decisions get made. That's where we look at the surface area of the packages that we're using and think, do I need a new library for this? What are the patterns that I'm using in the code? Are there new architectural elements that are needed? And we take the features, and or whether you call them story cards or product backlog items or whatever they happen to be, and we start splitting them up into development tasks or smaller story cards that are individually workable, so that a programmer can take one of the cards and implement it, within a day, within a half day, because we don't want someone to take a card and then work on it for days on end. We want to have bite-sized chunks, and so we split it up. But then the last design column is test design. That's the definition of done. That's where acceptance tests get laid out. These are just test scenarios. And for any given change to the software's behavior, we should be able to figure out how we're going to test it. And these are just bullet point scenarios. These are not big test documents. These are just, small 4, 5, even 10-word descriptions of a scenario that we're going to run it through. And so to integrate test thinking into this, you would have some test scenarios that explicitly call for attempting to subvert or thwart or compromise data, things like that. All right, let me go forward. So that's how you lay out your process. And then, of course, after development, it's a mirrored validation. We validate functionally, we validate on user experience and what we can see with our eyeballs. And then we validate the release. Are we actually ready to deploy to production? And that includes visibility to telemetry and logs and scale and performance and things like that. I want to start kind of the last section on runtime and production with the OWASP Top 10. Again, if you are already familiar and already making sure that this is incorporated in your process, fantastic, you're awesome. If you are not using these in your current team, then go educate yourself on what these are and just start using them. Again, it's not rocket science. I would say the 80-20 rule, 80% of the benefit is just being aware that these are really common and that they have actually really common solutions and risk mitigations as well. Over the last 4 years, there has been some movement in the priority of each one of these. At the same time, a lot of them were a top 10 in 2017, and they still are top. Actually, there's only 3 of them that just poked into the top 10 in 2021, and that's insecure design, software and data integrity failures, and server-side request forgery. So if you look at broken access control, that was number 5 in 2017. It's number 1. Sensitive data exposure, it was number 3, and now it's number 2. But of course, they renamed it to cryptographic failures. So some of them have been top 10 for a while. They just kind of are jockeying different positions. So be aware of these, educate yourself and your team on these, and just evaluate your software for these vulnerabilities and make sure you have a mitigation. And then finally, runtime security. We all like to think, you know what, I'm using a professional data center. I'm using Microsoft Azure. It's all secure because of the physical security in there. And that's all great. It's very unlikely that somebody's going to be able to, just run through the gates of a professional data center these days and get physical access to a cabinet and start plugging in wires. If you, like in Texas, if you've ever toured a rack-based data center, you see armed guards with very intimidating looking weapons that are standing guard physically over the actual premises of the building. But it's not that. It's the It's how we use the physical security and how we decide to alert ourselves about that. But you notice that I use the term runtime. Runtime security is not the same as physical security, because we can actually gain access to a software system without being physically present, right? And so a few things to use. There are Microsoft security recommendations on Azure. Make use of those. Also use SIEM, Azure Sentinel. By the way, SIEM stands for Security Information Event Management. And then for every programmer, when you're thinking of what to put in the logs, what kind of telemetry, that topic is alerts versus alarms. And so you could have something that goes into the logs. Great. But are you going to alert people to that? Or are you going to sound the alarm? Now, first of all, you have to have good logs. You have to have good telemetry. Azure Application Insights is your friend there. Of course, there's a lot of good products around there that do a good job, but you're going to emit events, emit metrics, all kinds of things. But some of them represent something that people on your team need to be alerted to because it could be concerning. And so you need to identify which those events are. And then alarms is a different type of alert. It's a type of alert that passes some type of threshold where everybody needs to be alerted. It could be an all hands on deck, or it could be if you have a dedicated team monitoring it. It is something that's not just a, hey, just thought you should know. It's a, no. There is a problem here, and there is something that somebody needs to do right away. That's an alarm. And an alert can become an alarm whenever it passes a particular threshold that you configure. So make sure that you've had the discussion in your team and ask about what should be alerts, what should be alarms. Now, of course, functional things like CPU, memory, that could fall into that category as well. Maybe you need to scale the software or whatnot, something went offline. But from a security perspective, yeah, if somebody is sitting there on a login page just guessing password after password, or a password bot is trying to do a brute force attack, well, guess what? You need to have something automated that's detecting that and either automatically mitigating it, alerting. And in the case of, well, think about this. If somebody logged in after having guessed the password, beyond a certain threshold, you might not trust that login. That could be an alarm, or any number of other scenarios that are appropriate for your system. And then finally, maintain a formal on-call schedule. This goes not just for security, but also just for regular business operations. So if something happens, if you're going to have alarms, then you need to have an on-call schedule, because when an alarm happens, you need to know, okay, who's responsible for actually responding to the alarm. All right, that is a lot of information. Took it right down to the wire. I believe I was able to incorporate every question that was asked in line with each slide, but I love answering questions. So send me an email. .NET DevOps for Azure is the free book. Any of these topics at ClearMeasure, one of our architects can help you with. We love, taking on clients even for a few hours of advisement a month, all the way to our ongoing architecture retainers to help your team move fast and deliver quality and ultimately run your systems with confidence. So if we can help, give us a call, send an email. And this was a lot today. So thank you for your patience there, and have a marvelous Monday.